Welcome to Programming Rainbow. In this video, we will continue on the series of Conway's Game of Life written in the C language and SDL2. This video will be specifically focused on the Makefile that has been used in this project. So let me just show off the project real quick, just so you can see what it is. This is Conway's Game of Life. I'm just going to run it. And right here we have each generation of the simulation happening. Some of the things are stable, some are doing things. We can actually click on this one. So you can kind of look up what Conway's Game of Life is. I'm assuming you already know what it is. So this is just the program that we built in the last videos. But this one I want to actually show the Makefile that I'm using. So this is the Makefile, and all the Makefile is doing is automating the build process. So we can just compile this thing from the command line. So we could use GCC, we could just compile the whole thing, and I'm going to call it, say, test or something like that, right? So we could say GCC, and then what I'm going to do is, this one already popped up, so I'm just going to kind of edit it. The files that I'm looking for are in the source directory, and I'm going to choose all of the C files. I'm going to output it. The binary that I want to build over here is going to be called demo, and I'm linking it to SDL2 and SDL2 image. And we're also going to need SDL2, so that's -L, the small l, and then SDL2 TTF, and then -L SDL2 mixer. And if this does build, these two ampersands is going to say if that previous command worked, if this compiling did actually work, it's going to then run the demo. So let's see if that works. Okay, so that just built the thing. Now I have a bind over here called demo. I also have a Game of Life one that was generated from the Makefile, but I also have and this one, I didn't really add anything special. I did the bare minimum I need to build it. Basically, I told GCC, I need all these source files built. This is going to be my output, and I need to link against these. These are the libraries outside of the standard library that I'm using. This is not really optimal because you may have a bigger project. You might not want to recompile the thing every single time. You also may want to use extra flags. You may want to use stricter flags, like these here. You may want to add in all these. So it gets a little bit interesting if you want to start doing all that, because, and also you may need GCC to know where SDL is installed at. Because if it's installed in a different place, then you need to let it know as well. I'm using package config in this to kind of find. I try to do this for portability, so people on different systems that would be able to find what it is. So if we used a command like this, I'm just going to yank this down here and throw it down here. I don't want to run this command. There we go. So if I use package config, and I'm basically saying where are the includes for these packages. And this is going to add in all the ones we need for my system. Package config was able to figure it out, and this is the output of that. And the same is true for the libs. It's putting this. So already we have a much longer. Basically, you would end up needing to write more and more things. You could manually write what package config outputted. You can manually write in, like I manually wrote in these here. But then when you start getting into like the sanitizer, the warnings, what flag, it starts to become a lot of stuff to type into the command line. And also, you're not really taking care of that. Like maybe you only need one module built instead of the whole thing. Like you can build these separately, each C file as an object file, and then link the objects files at the end with the linker of whatever libraries you're using to build the final binary. And that starts becoming much more complicated. So we use these Makefiles to kind of deal with all that. One, it's going to allow us to build it separately. It's going to allow us to put the switches in that we want to build without having to retype them over and over again. It's also going to only build the stuff that we need to build. Stuff that's already been built that doesn't need to be rebuilt, it will not do that. So it kind of speeds up the process. If we just need to recompile something because we changed one line in one of the source files, it's only going to rebuild that one object file and then relink the final binary. So that's what the Makefile is doing. So let's just kind of work through what it is. I'm going to do this a little bit backwards. Instead of last time I went from top to bottom, this time I want to focus on what the Makefile is actually here for, and it's to build the final output. If I was to take this right here, let's just decode what this is real quick, okay? So this CC right here is here. So this CC is a variable assignment, but this is conditional variable assignment because there's not just an equal sign, there's a question mark. That is saying if this is not yet set, then we're going to set it. If it has already been set, then we're going to ignore this. So if CCC has already been set to something, it's not going to be set to GCC. But if it hasn't been set to anything yet, then we're going to assign it GCC, okay? So anyway, we'll swing back around to this in a little bit, but I just want to say it's GCC. So this variable CC equals GCC. Okay, so let's just kind of write out what these are doing then. So GCC, that's CC, and then we have libs. So libs right here is defined again conditionally, and it's just the libs is libs base, and we've already seen this conditional assignment. But this is just the variable being expanded. So let's find out what this variable is. Just like this $sign here on libs is this variable being expanded. This is being set to this variable being expanded. So I'm going to go look for this. This is libs base. Is it right here? Which is nothing. Okay, cool. It's actually being set here as well. So it's first being set here to nothing. And I will cover this in a minute. But it's also being set here with the output of this package config. And we've already seen what the output of package config is. So I'm just going to do it again, yank it again real quick, just so you can see it. Okay, so that is the output of that. So let's just grab this. And we'll put it here so it starts to make more sense. Okay, so that's right here. So I'm just going to tell you what this is. I should have done that first. Right here, this is a rule of Makefile. So this is called a rule. This expansion of this target variable right here is actually called target. It has nothing to do with the fact that the variable there is called target. This is just the target of the rule. So anytime you see this with the colon and then some other stuff, this is a rule, and this is the target of the rule. This over here are the prerequisites of the rule, things that need to be built first. And these should not even be here. That was when I was explaining something else before, which is fine. Okay, so that was a mistake. That was not supposed to be there, but it didn't hurt anything. So this is the target of the rule. This is the prerequisites of the rule. Okay, this is the recipe of the rule. So imagine you want to bake something. You want to bake a cake. Okay, your target is the cake. This is the target. This is what I'm baking. It's the cake. The prerequisites I need is like flour, milk, eggs, butter, a mixing bowl, an oven. Those are prerequisites. Okay. And here is the recipe. This is how I'm going to take the things, mix them all together, and then cook them. So this recipe has just one command in it, and it is this GCC with these libs right here. But this guy right here is the expansion of all the prerequisites. So this is saying all prerequisites. Now, I'm just going to tell you that this right here is a list of object files. So these OBJs, these are object files. They're actually set up here. Or is it right here? I'm going to come back to this, but I'm just going to tell you before I deleted this other thing right a second ago. It's basically each one of these source files. We're going to swing back around to this, so don't worry if you don't understand it. But each one of these, I could compile these separately into an object file. I'll show you real quick. GCC, source, and we'll say board C. I think I need to do that. And then I will output it as board.o. Sorry, that should have been an O there. That should build a board object file here if I haven't totally missed something. Okay, so there's the board object file. And I could do that with each one of these source files. So I'm just going to do that real quick. Yeah, there we go. So this just compiled all of these that were in source directory that were source files. It compiled all of them into object files separately. And then I could take all those object files, which are in the top level directory now. So I'm going to do star.o, and I'm going to output them to, I could output them to game of life, or we could call it demo2. And we do need now to add in these linkers. And I'm missing one here. I'm mixing mixer. Fish is basically seeing that I've typed in a similar command and it's auto-completing for me. Okay, so this linking of these libraries needs to happen when we create the final binary output, but when we create these object files, we can do them one by one. And now we have demo2. Where is it? Demo2, and we can run demo2. And it still works, right? So basically, these object files are going to be created. So it's basically saying to create this binary, this game of life binary, I first need something had already built these object files. So this rule is taking object files and creating the final binary. So this right here is actually a list of all of these board.o, fps.o, game.o. It's a list of those things, okay? So let's do that. Let's take away this and put in those names. And I'm going to put them in the top level directory because I just built these in the top level directory. So I'm just going to put them here. Board.o and fps.o, game.o, init, SDL.o, main. Is that all of them? Message. Okay. So now we're so far here. We basically have done, we've got GCC. We have the libs, which are these, and sorry, okay, mixer's not here, but it said it wasn't, and that's fine then. Let's just make sure I did type that in with mixer earlier. I did not type it in with mixer, so I'm going to add mixer here. So it looks like I do need mixer in there. So I'm sorry I missed that one, but we'll just add it. I put this in the wrong spot. Let me just cut this real quick. Okay, there we go. So I'm trying to write it down here. So -L, and we do need this SDL2 mixer. That was something that I missed because I didn't type in the command correctly. So we have the CCC, we have these libraries. This guy right here is saying all of the prerequisites. This $ and caret is saying all of these on this side of the colon right here. This is the target. This is the prerequisites. Whatever's here, all of this stuff here, which will actually be, let me just paste it. All of these would actually be what this is expanded to. Okay. So that's what this is. Now we have that an O. So -O. And now this one right here, so the caret expands to all prerequisites. The @ symbol expands to the target. So whatever this target is, let's find out what this target is. Target right here is game of life. Okay. So what we're actually building is game of life. That's the name of the target. And so after the O over here, I'm going to put game of life. Okay. So that's what that's what this rule right here, this target is game of life. Actually, that's here. What these objects are all of these O files. And then the recipe is saying GCC, take these libs, take all of the prerequisites, which are these O files, make an output, that's -O, and the name of the target. This $@ symbol is the target. That's game of life. So let's just test this command out real quick. Okay, that looks like the command that I copied correctly. Hopefully I didn't miss anything. And it did. So let's I'm gonna remove game just to make sure we did build it. Okay, and there's Game of Life, and let's try it. Game of Life, and there's Game of Life running. Okay, so that's kind of us going through decoding what this is. This is the target to the rule. These are all the prerequisites. This actually expands out to a list. We'll see that in a second here. This is the command gcc. This is the libs that we have a complicated process, but we'll get to it. And this is just saying this is just a variable for Makefile that says all prerequisites. This is a variable that says the target. So it expands out to this, okay? So we had this object, so that was a prerequisite. So what happens is I actually need to build the objects first before I can build the target. When this rule hits, it's going to say these objects need to already exist. So what are these objects? Well, these objects are a list of they're a list of .o files, and we're going to have to talk about this in a second. I'm just kind of doing this backwards. So it needs a rule to build these object files, okay? And these are the rules right here. These are all the kind of base rules right here. So this rule is to build a target. We already know it's called Game of Life. This rule is different here. This is a rule that is pattern matching. It's saying build something that is in the build directory. And when we get at this later on, these object files are in the build directory. Just trust me right now. We'll come back to this in a minute. But these object files get built into this right here, this directory here. These are the O files. So it's saying I want my prerequisite list is actually a list of .build / some name.o. So that's what this is. This is the .build directory, which we can look up here. It's .build is build directory. So something in .build directory with some name.o. So this is going to have like the .build directory board.o up here. Board.o. That's one of the prerequisites that's going to be in this list. So this goes up there and says, yes, I can match on that pattern. Okay. This % is going to be board. Okay. So it's in this directory. It's called some wildcard name that we're going to match on, and .o. So there is board.o. That was one of the prerequisites. It needs to build it. And so it is saying I need a prerequisite to build that to be the same name, but in the source directory, which is down here. And I need it to be a .c file. So it's going to say, does board.c exist here? That's a prerequisite. Yes, it does exist. So this is a prerequisite as well. And this % is whatever pattern matched here. So when it does board, it's looking for board here. When it does FPS, it's looking for fps.c here. When it does game O, it's looking for game C here. This is called prerequisites. These are normal prerequisites. Past the pipe right here, this is called order-only prerequisites. This is a prerequisite that is required to already exist, but it doesn't affect, if it changes, it doesn't affect the build process. So if this C file does exist and this O file does exist, and they have not changed since the last time I built it, it will not be rebuilt. But if this O file does exist and the C file has since changed since the last time I built it, this Makefile will say, look, the C file has changed. I need to rebuild this guy. But if what is in this directory has changed, it doesn't care. It just says the directory needs to exist. If it changes, it doesn't matter as long as it exists. So changes in prerequisites will cause a rebuild of the object file. Changes in this build directory right here will not cause a rebuild. As long as it exists, it just needs to exist. So this build directory right here is this .build. It's saying that needs to exist. Before I can start putting object files into that directory, it needs to exist. So we have a rule of build something that is a .o file in a build directory. It's got a prerequisite of that same name has to exist in the source directory as .c, and the build directory must exist. So when this target here says, hey, I need build.board.o or build / board.o, it goes up here and it says, yes. Does the C exist? Does the build directory exist? Now let's build that thing. So let's look at this. CCC is GCC. This C flags right here is going to be the base one here, which is I'm just setting it to C11. That's the base. But down here, this is actually going to add in the package, and we're going to cover this in a bit. It's going to add this in. It's going to add this in. So that's a whole lot of information for it to add, yeah? So I'm going to yank this. Where is it? So we have GCC, and then we have space, and we have all this. And it's probably not lined up right, but it's good enough. You understand there's a lot of stuff here. Okay. And then these two right here, we're going to come back to them in a minute. They're all about making these .d files up here. So they're just more switches. And then right here, now this one's different. We have a $sign, and this is like I think the greater sign. Sometimes I might get it backwards. But anyway, Pac-Man eating to the right. This is a new one. And this says the caret was all prerequisites. But this symbol says just the first prerequisite, just this guy. This is not a list. This is a single thing. Okay? This first prerequisite here is going to be, if we're building board, it's going to be source/board.c. So let's do that. So -c, and then we have source/board.o. That's just one example of what it could be building. If this was .build board.o needed to be built, then this is what's here. And we have the output. And we see this $@ symbol. That is the target. So that is this guy right here, which will be .build/board.o. Sorry, this is a .c. Okay, so that's what this equates to. So basically, when this thing wants to build the final binary output, it goes through all the object file and it does this thing. It runs this command for each of them. This is a wildcard. This board here gets switched out for board, FPS, game, the init, SDL, and main and messages. And so this is a pattern matching one. This %sign is used to say, to build this object file, we do need the source file, and we need the build directory to exist. But it's checking to see if this has changed since the last time we built, which gets timestamped. So Makefile handles that. And what these two are doing right here is creating these .d files. See if I can open one of these up. So what these do is they generate a phony build for like a phony target. See, here's the target. Here is the prerequisites for this target. So it's saying, yeah, if you want to build .o, we need the C, we need the .h needs to exist, and the source main.h, because I included that into the board.h. So this is more comprehensive of what actually needs to exist. This gets generated by GCC. It creates a fake, a phony target. That's what this is called. This is a phony target. I'm not going to explain this too much. This is making dependencies about what needs to happen, okay? So that's what this -mmd and -mp are doing. They're creating a dependency list and creating phony targets. Okay, so that's not going to do anything the first time you build. It's just going to make the D files and it's not going to actually use them at all because they don't exist yet. But the next time you build down here, this includes all of those into the build process. So it'll actually not just recompile if the C changed, if the H file changed, it'll recompile, or if any other dependency of that file changed, it'll recompile. So this makes it much more dynamic. So when you change a file, your target object file will actually be rebuilt if some dependency of that file did change. Okay, I know that's really complicated, but anyway, so that's what this is doing. So basically, this has a whole list of all of these right here. It has a list of these. This objects is a list of those. And it's going to go through each one of those, and it's going to go up here and build this. And it's going to say, I need this first and then this first. And this is what it's going to look like. So I'm going to get rid of this now. I'm not going to actually run that command, but you get the idea. So the very last kind of true target we're dealing with here is just the build directory. Remember, we had this order only prerequisite. Well, this order only prerequisite is just about building the build directory. And the reason why I have it here like this is because I don't know if you're on a Unix style system or a Windows style system. So I have separated these out. So up here, I do have this block, and this basically, and I do not 100% know if this is correct or not because I have not tested this on Windows. So it may or may not work on Windows. Plus, I have no idea where stuff is installed in Windows and everything else. But it's trying to see if this variable OS is Windows NT. And again, I don't know if this works on across all Windows systems. I have no idea. But if this does equal NT, it's going to use, it's going to check to see if package config is going to installed, and then it's going to, the clean command is going to be one command, but we're looking for this make directory. This in Windows is if not exist, this directory, make the directory. And in Unix land, everybody else, it's just make directory minus P directory. So it preserves it, right? So that's what we're really looking for. It's going to be one of these, this one, or in Windows, it may be this one up here, if that does work correctly. So basically, this has the prerequisite of all these objects. That those objects will run through here. Those prerequisites will check to see if the C file exists and check to see if the make directory exists. If it doesn't exist, it'll make the make directory here. If the C file does not exist, it'll probably just fail. Okay, so that's how these work. So I'm going to go up here now and just start talking about these. So these are just the variables I'm setting. The target, I'm just setting it, the name of the output binary I want to create, called game of life. The build directory, it is in .build. Those are just direct variable assignment. And these are conditional with a question mark. That means I can build what's in the source directory, but I could change this to also build what is in video 1, video 2, video 3, and stuff. So let me just show you this real quick. I'm going to remove these .o files and remove this demo 2. Okay, so let me just show you kind of the output of some of these things. So the way I can just print an output is by using a built-in function, and I need to use the $ like this to evaluate this function. But it's called info, and it's kind of like a print statement. So I can say info, and I just want to print out what the source directory is, okay? So, and we could also print out what CC is. So I'm going to say source directory, and then I'm just going to let it expand the source directory variable. So it's going to print this word and then print what it is. Source directory. And I'm also going to do the CC as well. And let's see here. Okay. And what I'm going to do here to just run this Makefile, but I don't actually want to build anything. I just want these to get printed out, is I'm just going to run make clean, which just cleans or tries to clean it if it's there. So, because I actually don't want to run anything. I just want to run the Makefile real quick. So I'm just going to say make clean. We'll get into that in a bit, but I just want to see if it outputs what these are. Okay. So right now it says the source directory is set to source, and CC is set to CC. Now, this is an internal thing. This is kind of threw me a little bit. It's not actually setting to GCC because this is being internally set by the Makefile to CC, which works on my system. It's fine. But what if we wanted to overwrite these? So CC equals, say, GCC, and then source directory. And I don't have to do both of them. I can just do one of them. Say I wanted to build what's in video 1. Video 1. That's in this directory here. Let's just go over and I'll show you. It has the source code from there. If I wanted to build that instead, okay, I'm just going to do the make clean again. I'm not trying to build it. I just want to print out what those variables are. So do you see the variable change to video 1 and this one changed to GCC? And if you were running, say, Mac, you might have Clang, and there's Clang, and you get the idea. So it allows me to override these from the command line. When I run the Makefile, I can put in my own switches and override them. So that's what's going on there. Let's close this. So what I'm doing here is I basically have different situations depending on how I want to build the project. I'm going to have different things as my C flags and my libraries that I'm like my includes and my different C flags, and also the libraries that I need to link to. They might be different depending on how I'm building it. So what I've done here is I've done a base one saying, you know what, my base flags, I'm just going to set the standard that I'm using for GCC or Clang to be C11. That's what I'm targeting, and nothing else. But down here, we'll come to this in a little bit, but I am adding to it what package config is adding. So I'm going to do that as the base, and then I'm appending to it. This plus equals is appending. Okay, and let's just look at this real quick. We've already done this. You already know that this is going to print out the includes, and this is going to print out the -L library bindings, right? So we're looking at the base flags right now. What this shell right here, this is a Makefile function like info that we just ran above. And it's going to say, I need to run something in the shell, and what I need to run in the shell is the rest of this. So this is my shell command right here, and this is telling make, I want to run this shell command. So this is evaluating this function, this shell function, that's going to run this in a shell. This is more platform independent because it's part of the Makefile. Okay, so basically my C flags is going to be -std C11, and then whatever comes out of these includes. And then I'm just going to, if I haven't overridden it, I can override that too, because I have these question mark equals. But if I haven't, I'm going to set that as my C flags. And then there's my C flags for here. And the same story's going on with the libraries that is for when we build the final target object, we need to link the libraries. So that's the basics. That's the base idea. But sometimes I want to make a release build or a debug build. So that would be a normal build. If I was just building just the normal output, I just wanted to run make and it builds it. It's going to do that. Very simple. But when I run release, I'm going to use these C flags base that we used up there. But I'm also going to use the C flags strict and the C flags release for when I want to do a release build. And when I want to do a debug build, I'm going to use the base and I'm going to use the strict again, but this time I'm going to use the debug flags. So basically, these are going to make the build process different. So let's back up a little bit. Sorry about this, but I've told you that this is a rule. Here's the target, no prerequisites, and this is the recipe. Here is another rule. We have the target, we have the prerequisites, order only prerequisite is part of that. And here's the recipe with just one command in it. Here is another rule. So these are real rules. They do a real thing. And right here, we're creating phonies. These are phony rules. They're not actually building a real thing. So if I were to run make all, what would it do? Make all will just build the target. So if we look at this, here's our target is all, which is actually nothing. It's just a phony rule or a phony target. But its prerequisite is to build the target. So it's going to say if the target's not built, if that, then go back and do this, for this, go and do all these and all that. And it's going to build that. So the all is just a phone rule for making the target. I don't need to know the name of it or anything. That's just all. That's a phony. The release is the same. The release just says, oh, run all, which is target. But before it does that, for the release rule, we can actually assign what cflags is for the release phony target. So I'm basically reassigning what CF flags are and LD libs when the release target is set. So this allows me to build normally. This allows me to change my flags and my linking, but still use the same build process up here. But these C flags will be equivalent to this now, not the simple one. So what am I doing up here? So I'm set the target. I have the build directory. I have the source directory. I'm setting my default compiler here, which is actually just using CCC. So here's my base flags, right? And we know that we're using package config to add the SDL information onto it. But if I want the strict mode, I'm adding in all this other stuff. This is saying, hey, warn me about lots of different situations that I may be making a mistake. And on top of warning me about it, turn all those warnings into errors. So you can look up each one of these separately. I'm not going to go over all of them, but basically it's going to add these together. So this is going to be there, and then all of this. And that's just for the strict. If I'm building the release, it's also going to do this, which is this minus capital O3 is optimizing. It's going to optimize it. So the binary will actually try to be optimized to run faster. And we have some other flags going on here. So when I run the optimization, or the release one, sorry, I'm getting this, I'm getting all these, this, and also the output of this one here, this package config as well. That's a lot of information. That would be a lot to type. And also we're adding these if it's the debug, sorry, not the release one. So that's the release one. On the base libraries, we have nothing we're adding this to the release one. So we are adding something else to the release one. And then we are also, there's no strict one, right? No. We are also adding down here what the output of this would be, so it can properly find where the SDL libraries are and link to them. If you had other libraries that you were not using package config for the libraries here, you could just add them up here into the base right here. So let's say you were you needed the math library, you do -LM. Say you were doing you weren't using package config to find SDL. Just as an example, I could say -L SDL2 like that. But since it's already down there, I'm not. So if you are using package config, you can just add them in here. If you're not, you could just add it in here. So that allows me to basically add all these strict rules to it and then add any release specific rules on top of it and any release specific library linking on top of it. So it allows me to say, oh, I want to build it normally, which is not too strict. I want to build a release one, which is going to be very strict and optimized. I want to build a debug one, and the debugging one is going to leave in the debugging symbols, so it's not optimized here. And then it leaves in these debugging symbols and sets up the GD debugger and all that stuff. It also looks for stack protection, other things. So you, like I said, you can look up what all these are. I'm just explaining how this Makefile is working. So I basically am just setting different flags that will be in place depending on how I want it to build. So on these phonies, I can say make all, or I can say make release, or I can say make debug. Now, when we do make clean, we have no prerequisites, but we have one command here, and clean is another one where it's platform specific. So in here, clean, I need to delete the target, the thing I built, which would be the game of life, but I also need to delete the build directory. So I'm hoping this is the way to do it in Windows. But in Unix systems, we can use the rm variable, and it's kind of already set by the Makefile. This is a rm-f already. So this has already got the force flag on it. And remove the target and also remove the build directory recursively. So those are platform specific. And when I'm doing the debugging as well, there's debugging stuff. Fsanitizer doesn't run on Windows. So I'm adding in the Fsanitizer here and also the library linking for it as well, where it's not in the Windows version. And these are appending. Okay. Now, the only other thing in here that I haven't talked about yet is this making sure package config is actually on the system. So this is a shell function, a Makefile shell function right here. So this is what it's running on Windows, and this is what it's running in Unix land. So let's look at this. So this is giving us a true or false back. It, literally the string yes or no. Sorry, if package config is installed or not. So this is what it is actually doing right there. And if we spell it wrong, like if we were looking for another package that wasn't installed, we would get this where no output. So we get an output or no output. You could also use which. Sorry, it's not V. There's no V in it. So there's which version, and if we spell it wrong, if the package was not on our system, we get that output. So what we're doing here is we are taking the output from this command and we're sending the standard output to dev null, which means there is no output. That is what this is doing right here. Sends the output to dev null. If we use the other command and I spelled it wrong, and we used which, well, I'll spell it right first. We get no output, but if it was the wrong thing, we do get an output because that's not going to standard output, that's going to standard error. So this is saying send the standard output to dev null, which makes it disappear, but it doesn't send the standard error. So then what we can do is we can say to, which is the file descriptor for standard error, not standard output. And we could say send to into the, I'm going to say it wrong, the file descriptor, the address of the file descriptor, I think. It's probably wrong what I'm saying. But anyway, send the output of 2, redirect it to the output of standard output. So take standard error, redirect it to standard output, and standard output is going to dev null, so we get nothing in both situations, whether it's spelled wrong or right. Okay. We do, however, get back whether this command ended correctly or not. And I'm in Fish and I forgot. It's something like echo status. Yeah, that's because I'm not in Bash. I'm in Fish right now. So I think in Bash, let's see. In Bash, what is it? I'm just going to take this up here. Yank, let's see. Okay, so if I did that, then I can go echo, so question mark. Okay, so that's 0, but let's check this command and let's make it fail. Which, and we're going to spell it wrong, so this command should fail. And this should be a 1 now, or a -1. I think it's a 1. See, that's a 1. So this command failed, and the echo is telling us that it failed. It exited with a 1. Now, this echo command succeeded, so if I run it again, it's going to be 0, because now this is telling me about this echo command, but this one was telling me about this. So what if we go up here and spell it correctly? Now, if we echo it, it's going to be 0. 0 is success. Okay. So in Fishland, we can do this echo status, and that's going to do the same thing. So that one, and then if we spell it wrong, we'll get a 1 on it. So it is telling us there is an output, true or false, whether this succeeded or failed, but we're not seeing an output. So what they're doing is, or what I'm doing here is I'm taking we're not seeing an output because we're directing both standard error and standard out and standard error both to dev null, so they disappear. But we do know if the last command succeeded or failed, and that's what the ampersand does. So this ampersand says, if this command here succeeded, echo yes. If it didn't succeeded, it won't do anything. But this or here says this one or this one. So it's going to say no. So it says yes. And then if we spell it wrong, it'll say no. Okay. So that's just saying yes or no. Is this installed? And this works both ways if we're doing the which command. That one's spelled wrong, and then I'll spell it right. And that's on the system. Okay. So basically we're putting the string yes or no into a variable here. And it's dependent on the system. So we're using a different command, but we're putting this yes or no in this package config. And then down here, we're seeing if package config is installed. So if it is yes, if this equals yes, package config equals yes, then we're running our package config commands. If it equals no, then we're telling you, hey, you need to install package config to run this Makefile. So this is just all about me trying to make this work on different systems. So this is setting up Windows or Unix, and then this is double making sure you have package config installed since we are using package config. We already have seen this. We know what these are. So these phonies, you can set them up. This one just builds the prerequisite, which is the target. This one changes the assignment of these variables based on if you are using that rule. If you're going to use this rule release, it's going to assign CF flags based on that and LD libs based on that. So that allows us to change the way we're building it, but it still builds all afterwards. So it's going to run all these commands up here, but these CF flags are going to be based on what was set here. Okay. Then we have clean, which just cleans it. We have run. Run, if the target has not been built, it has the prerequisite of building the target. So it's going to build the target. And then we already know what this is. This / this is saying run something in this current directory, which is the binary. But this right here is the Pac-Man eating to the right is the first prerequisite. Well, the first prerequisite is the name of the binary, which is Game of Life. So this is saying, run is saying, make sure Game of Life is built. It's a prerequisite. And then it says / Game of Life to run it. And if I want to rebuild, you can stack these up. I can just say clean, run clean, and then all, right? And you can kind of stack these together as well. So I hope I explained most of these. Okay, I know I skipped something up here. So let me go right here. We haven't tackled this yet. So let's get into this. This is the little bit complicated, but not too bad. I want to basically list off I want a list of all these files, right? So I could do something like this. So I could do something like this. Now I'm not actually using the ls command because I'm weird. Bin ls. There we go. There's the normal ls command. So basically this, right? I need this list of source files, right? Which will be my sources. But in the Makefile, I can't just do that. That would be this right here. I need to say wildcard. When I say wildcard, then I can do this. This is src / and I can use this wildcard C. So I'm going to get a list like this right here. When I do that, and let's just print it out. And say sources. Sorry, that's totally not right. Okay. Okay, so I'm just going to run a make clean on this just so we can print out what that is. And it should be very much like this. Here it is. Sources, that's what this is setting to. So this gives us a list of all the source files. Now down here, we're a little bit more complicated. Right here, this first thing is a pattern matching replacement. Here, let's just output that first. I'm going to still say sources, but I'm going to do the same thing. :C equals .O. So we should get these sources, but we shouldn't get the .Cs anymore. We should get the .O versions of them, if I've written it correctly. Make clean. And yeah, see, we have a list now that was based on this, but we replaced all the .Cs with .Os. So this one right here, this expands to this variable, but we're doing this, I forgot exactly what it's called, but it is like a pattern matching replacement. We're looking for the pattern .C and we're replacing it with .O for the whole list of these. But what we want is we want no not directory on it. So it's going to strip this source / off the front of it. And so let's just do that as well. This is a function that's built into Makefile again. So I'm just going to print this out now. Okay, so now we have just the object files without the source / because what we really want is it to be build.build, right? Because we're trying to build it into that build directory up here. Where is it? Oh, it's not here yet. It's been deleted. But so what we're going to do is we're going to append a prefix and the .build and then / onto the front of it. So I'm going to do that here. This is another function. And I need to close off another parenthesis on the back, I believe. Hopefully that's all written correctly. So that should give us .build / and then all the O files. Okay, there we go. So basically, I've got a list of all the sources that are in the source directory, and that is set based on whatever we set the source directory to. And now the objects are a list of where all the target object files need to be built at. And they'll be in a hidden folder .build and then / and all the object files. Okay. So now I also need a list of dependencies. So I'm just going to undo this a couple times to make it simpler. So right here, all we need to do to get a list of dependencies that are also supposed to belong in the build directory is just do that pattern matching replacement where the .o equals the .d. That's all we really need to do. So I'm going to say objs : .o equals .d. So this will give us a list of all those now. Okay, so now we have these dependency file lists. So this gives us a list of sources, a list of target objects, and a list of target dependencies. So that goes through what that was doing up there. And we know that this MD is creating those .d files. Both this -mmd and this -mp creates the phony builds within those .d files. And then down here, what this does is this includes it into the Makefile, but in such a way that it doesn't, if one of them are missing, it won't cause it to fail. Okay, so this is trying to get a proper dependency list of each file that needs to be built. The very first time you run make, there will be no dependency files. So there will be so when it goes through, it'll build the dependencies, but this won't exist yet. So it won't be using them the first time, but when you rebuild it, it'll then be using those dependency files. So I can say make run, and it's going to create this build directory here. It's going to compile it and then run it. And if we go back, we can kind of see what happened here. When I did make run, it did its make directory, right? This is the Unix one it was doing, because that's the prerequisite that the directory is there. And then it's running the cc command with all these includes, and it's building this object file. Here's the source C and the board object file. Then it's building this object file and the next one down here. It's going through and it's building all of those. And then on the final one, right here, the message is the final object file it built. Then it does cc. Here's the LD libs, which are basically just the SDL libraries it needs to link to. Here are all the objects it needs to, and there is the output game of life. And then after that, since I did a make run, now it's running that game of life. So if we go down here, I could say make clean, and then I could say release, and it's going to build it differently to build a release version. And we will see that when we go up here. There should be -03. These are optimized builds. And the reason why I did a clean is because if I would have just done, well, I'll do it on the debug. I want to make the debug, and we end up with a little bit of a problem. It'll say that the binary is already built and there's nothing to be done. See? So whenever I go to change something, if I was building it for a release target, I'm not going to rebuild it again if I'm switching to a debugging target. I need to clean the whole thing first. If I'm building release over and over again, then I don't need to do this clean step. But when I'm changing the way or changing the source directory or changing the way I'm compiling it, I'm going to clean it. So it'll be clean. Now when we're doing the debug build, right here we see this, and when we get through all of the warnings and everything else, we see that the debugging has a different optimization and our debugging symbols are in place and all that stuff. Okay? So let's see, I built debug, right? So if I go to build debug again, it's done. But what happens if we change a file? So let's say, I just want to change one file. So say in message, I'm going to put a space in between these two. Now, nothing depends on this. So the only thing that I should do is get a recompilation of message.o and also the final binary. So that's what we should see here. And since I built debug last time, I'm just going to type make debug again. Okay. So what was the output here? And we see that we are building the message and then we're building the final binary again. I'm going to undo this so I don't mess up where I was. I'm just going to rebuild it again. It's going to do the same thing again. Now, what happens if we do something that more things depend on? So message pulls in message.h, right? So if I change message.h, it's going to trigger the recompilation of message.o, right? But message.h also relies on main.h. So what happens if I go into main.h and I put in a space here? What's going to happen is it's going to rebuild the entire project because everything depends on this. So I'm not going to do a clean or anything. I'm just doing make debug. And now it should, it's rebuilt everything because everything depends on that H file gets brought into every project. That's a dependency of everything. I'm just going to rebuild it again. So you can kind of see when you change something, it only rebuilds what you need to rebuild. Since everything depends on main.h, everything has to be rebuilt because it could be something important. It could be a constant that is used inside of there, and that would cause a bug or an error if it wasn't changed the way everything else had been changed. So it only builds what you need to build, and nothing more. And then I can just say make debug run, right? And it doesn't need to do anything for the make debug because nothing was needed to be done. But then it can run it, or if it does need to do something, that thing will happen. But you need to think about, like I said, when you're changing from like a release to a debug or normal to, or you're changing the source, if I want to build what's in video number 1 or video number 2 where I just close the window. So I can say source directory. Let's just back up for a second. Yeah, I can use Clang. I'm going to put it on video number 2. So it's going to build what's in video number 2. And since I'm changing the source directory, I'm definitely going to do a make clean first. And then I could say release or just run. It's fine. I know what I did. Sorry. I put 02 here, and I don't actually have a directory named 02. I have a directory named 2. So I told it the source directory was a directory that doesn't exist. Okay. So this is much simpler. I built what's in video directory number 2 here, which allows me to open and close a window. So this allows me to go into different sources. You know, I'm allowed to have my stuff in source directory by default, but then I can redo it. And it should have been using Clang. Here's Clang right here was used instead of GCC. And if I wanted to check GCC, I could just set this or remove it. It's going to be fine either way. But think about things like the order of things. If I do make clean, that means I'm dealing with a clean slate. But if I do release, debug, run, or something like that, that's not going to work. It's going to build release, right? Or all and then run, that'll be fine. But if I do all release, it won't be. Release is going to be done after all, and all is just the base build. So release will say, well, the build is already done, and run will just run that, and it will not be release. So you have to think a little bit about what you type in, but it's pretty well overall. So we're assigning here. We're assigning to variables. This is a conditional assignment with the question mark. These are normal assignments. So these are just variables here. Okay. And when we get down to here, this colon equals, it's like an instant assignment. It's not called instant. It's called something else. It's assigning it instantly because these other ones, whenever you see this $, this gets evaluated. So this gets evaluated here. It goes back up and it says, okay, what is that? Where this one is evaluated instantly and assigned here. So it doesn't get evaluated later. These other ones get evaluated when they're used, where this one is like instant assignment, the colon equals. This one is a pending. It's like an append assignment. This one again is the instant assignment. These are appending. This is conditional assignment. So these are basically just assigning. And this is like an if the OS equals Windows NT, we're going to run this code. Else, we're going to run this code. This is making sure package config is inside. If it equals yes, then we can run the package config commands that append to our CF base and our LD libs base. Otherwise, we're going to stop the Makefile and we're going to print out this statement right here that tells you that you need to install the package config. We can override these. So these are conditional assignments, but we're just assigning whatever CF flags base ended up being to CF flags and the libs to the libs. These are rules. This is the target. These are prerequisites. This is the recipes, the commands and the recipes. Target, prerequisite, order only prerequisite. The recipe has one command in it. Target, prerequisite, recipe has one command in it. So when I want to make this target, the prerequisite is all of the object files. Each of those object files gets built here. This is the target for one of the objects. This is the prerequisite, the order only. This is the recipe that builds it. And one of them is also this, making sure the build target is there. So that is that's the bulk of all the compiling happening there. This is about adding in those .d files as phony build dependencies. And these are our phonies right here, all clean, run, rebuild, release. So these are not real targets. You can't actually build all, but it's a phony target, and the prerequisite is the actual target. The release, again, is just a phony. I could put target here or all, and I'm just changing the assignment of CF flags and LD flags. The same with the debug. Clean is just for cleaning it. Run, make sure the target is built as a prerequisite and then runs it. Rebuild just runs clean and runs all. Okay, so I hope that explains. If anybody was wondering about the Makefile, hope I explained it. If you have any questions, just let me know. And also let me know if it works in Windows. However, I have no idea what's the default way to install SDL correctly in Windows in the path. I don't know if there is a correct way to do that. I hope that was entertaining or educational, and thanks for watching. Have a good day. Bye.